Someone recently emailed me asking why her Blazor app's components and pages always seem to render using InteractiveServer instead of WebAssembly whilst defining render auto. So the expectation is when you load the web application, maybe for the first time, and the WebAssembly hasn't downloaded yet the runtime, it's going to use the InteractiveServer WebSockets to handle the interactivity. But then the next visit, let's say we refresh, the WebAssembly should be ready, loaded and ready to go. The app is expected to use the WebAssembly for its interactivity. For some reason, the interactive auto is not working as expected, so we'll find out why. She told me that she prefers to define the interactivity mode, the render mode, per component individually because some of her pages and components may need InteractiveServer, others she prefers interactive auto but expects interactive WebAssembly, and some pages can just remain statically rendered. What I found out is that once this WebSocket connection is initialized, which could happen by using InteractiveServer or interactive auto, as long as the WebAssembly hasn't kicked in, then that WebSocket connection is used for the interactivity. So if you then route to a different page, which may have specified interactive auto, then it's still going to use those WebSockets for the interactivity. It's not going to close the WebSocket connection and from then on use WebAssembly. So it seems like interactive auto will only use WebAssembly once WebAssembly is loaded and ready to go, and two, when there is no WebSocket connection established. So to mimic her setup, I quickly made a new Blazor Web App application with the server project Blazor Web App 1 and the client project Blazor Web App 1.client. I moved most of the pages inside of the server project just to see what was going on. Let's say the homepage there's no global rendering. So on the app, on the head outlet and the routes, there's no render mode defined. So we don't have any global render mode set. Then the homepage should render as static. And then I have this counter page, which should also render as static, but on here there's a counter layout component, which lives in the client project, and that one has defined interactive auto. And then I have the weather page to mimic that authentication, that login page of the person that emailed me. And this one has render mode interactive server. So what then happens is I go to the root route, which is the home page. There's no initialization of the WebSocket connection, and there's no message about Blazor WASM. If I then go to the weather page, which you could see as her authentication page or her login page, this is going to initialize that WebSocket connection. If I then go to the counter page, I turn off WebAssembly in my browser for testing, but the counter component works using the WebSocket, and I can prove that to you by going to the WS network tab, WS, inspecting the WebSocket connection messages, scrolling to the bottom. Oops. And if I now click, you should see new messages being added. Let's say we refresh on the weather page. Same is going to happen. It's going to initialize those WebSockets, go to the counter, and it should work. Now, if I would refresh the counter page, it should actually use WebAssembly. Since we're using interactive auto and WebAssembly, well, I turned off the support manually for now for testing, but if it was supported, it should choose WebAssembly for the interactivity. What is a bit buggy here is I turned off WebAssembly support manually, trying to click, well, I would expect the interactive auto to initialize the WebSockets because WebAssembly is not supported. It should actually use the interactive server, which is strange that it isn't working. Let's allow WebAssembly again by going to properties. I have those JS flags. No expose WASM, which I showed you in the interactive auto video that I did before. You can also do this on Mac. Okay, now I have to close all my browser windows. Now I went from the home page to the counter page and it initialized those WebSockets, likely because it didn't have WebAssembly ready to go. Only afterwards it did that. So now we can see in the network tab, got this one. Despite now having WebAssembly supported, if I now click on this, we keep using the WebSockets. If we now refresh on the counter page, which is using interactive auto, we get our WebAssembly and it's interacting with over WebAssembly. Since there's no WebSocket connection, let's see what happens if we now go to the weather page. We get that WebSocket connection due to InteractiveServer being specifically set on that page. And let's see what the counter now does. Yeah, it switched to that WebSocket, which is the WebAssembly is available, so it seems to prioritize. Let's see. Oh, wait a sec. Now it doesn't seem to be using the WebSockets. Let's see. Okay, so now it's using the WASM again. Let's see. Now the WebSockets. Back to the counter. Let's see. No, it's correctly using the WASM. Anyhow, to mimic her situation, we kind of always start at the interactive server, which initializes that WebSocket, which is the login page in her application. And we would then switch to another component or page that uses interactive auto. Let's do that. And then it's using the WebSockets instead of what she expected to use the WebAssembly. On refresh, we should be using the WebAssembly since there's no WebSocket connection. So the problem for her now is that she would prefer the smooth client-side rendering interactivity that interactive WebAssembly offers, but for the reason that I just showed you, her application is always interacting over the WebSockets, because what happens when loading her application is we first always hit a page that uses or a component that uses the interactive server and initializes that WebSocket connection. She likely won't be the only one with a scenario like this or an issue like this, since it's actually wise to maybe handle the authentication server side. But maybe it's a solution for her to just leave out that interactive server on her authentic login page, for example, and maybe just do it the Blazor static way. If possible, of course, it's not pleasant, and maybe she'll need to introduce some jQuery to add a little bit of dynamic user experience, but hopefully she could just handle it with Blazor static. Another possibility would be to somehow prioritize the WebAssembly render interactivity over the interactive server. So instead of allowing the interactive auto to decide, we would like to take control over that priority. So to prioritize that WebAssembly interactivity, we would need to check whether WebAssembly is supported. If it is supported, we'd want to use that instead of the interactive server, despite of having those WebSockets initialized. So one way to do that, in my opinion, would be to use some JavaScript to check whether WebAssembly is supported, and then you could set it into the local storage to then read out elsewhere in the application, maybe in the program CS. You could use the JS runtime to get the value out of the local storage, set it maybe in a global state property, and use that on your components to conditionally check or set the interactive render mode, like I would be doing on the counter, something like this. Priority render mode if render state dot, which is a custom class that I made, if WebAssembly is supported and the render mode isn't already interactive WebAssembly, then use interactive WebAssembly, and else interactive server. And then here we would do the priority render mode. Priority render mode. Now I just gave you a head start, but my solution is not entirely correct. I'm providing a few different ways to fill this property. One would be inside of the program CS of the client project. And similarly, as we did with the localization, we could get the JS runtime, call that method to get something out of the local storage. So hopefully true or false for is WebAssembly supported. Then we kind of need to set that property in our state. I don't think I'm doing it right here, but maybe you can get that to work. Perhaps we need to re-register that class after altering it or something like that. Another approach could be to use the on after render async. Do keep in mind that if you want to use on after render async, that you may need to have some sort of interactivity on the page that you're trying this, because that needs interactivity. So I suggest just enabling the interactive auto, which may be doing initializing those WebSockets. Our custom render state class and the JS runtime. Then we could use the JS runtime to get that value of is WASM supported, true or false, and then set our state. Since we're trying to get the value here, this is likely going to be too late to set the value. So that's what I mean. My solution is a start, but it's not a working solution. Another approach, so either on after render async somewhere, or preferably somewhere in the startup, maybe in the main layout or something like that, or conditionally, or put it in the program CS, but then you need to find a way to fix this. Then a third approach may be invoking from the JavaScript, invoking a Blazor method. Also, this one I didn't finish due to some other complications. So let's say we go back to the app.razor. Let's just allow this, just a setting. Well, let's see. But then using the JavaScript interop to pass the value for is WASM supported to that JS invocable Blazor method. Again, this is likely too soon to try to invoke a client-side method, so we may need to move this in some kind of conditional, or maybe after render or something like that, which, yeah, still haven't figured out where to do this, when it's too soon, when it's too late to try to get or set this value, because We want to render this component likely as soon as possible with the correct render mode. Let's see. That render state just has one property. I hope you get the idea. Then I was playing around with assigned render mode, and these render info.name render info.isInteractive. These are unfortunately .NET 9 features, properties exposed on the component state, which every Blazor component inherits from. But it fell short for this case because it's just telling you the current render mode. So the name could be WASM server and static, and then is interactive is just true or false. So, and again, assigned render mode is about the current render mode. So we can't really use these properties to check whether the different interactivity is supported. So let's say the WASM is supported. That's why I opted for a JavaScript way to check that. This is a very simple check. I think if you just Google how to check if WebAssembly is supported, you may get a function to check if it's defined and we can actually use it. It is unexpected that the interactive auto failed when I manually turned off the WebAssembly support for the Chrome browser. I'll have to check with the Microsoft team. Maybe that's not a good way to simulate that problem, to just manually turn it off. I was trying to mimic maybe an older browser that doesn't support WebAssembly, so a browser older than, or a browser version older than 2017. Those tend to not support that. Anyway, do you know a different approach or a better approach to check whether WebAssembly is supported and act on it, and prioritize the WebAssembly render mode when WebAssembly is supported? Do let me know in the comment section below. I may ask some questions to the Microsoft team. First off, is there a better way? There likely is. Secondly, why my simulation of a browser without WebAssembly support failed. This was an interesting problem to dive into. I don't have all the answers, but the person that encountered that issue is likely not the only one. So let me know if you've encountered something like this or similar. If you need help with your Blazor projects, you can find me or hire me on kisco.com/hire me, which leads to my Upwork profile. If you want a custom solution or just a consultation, then feel free to reach out. You can find my .NET 8 projects, fullstack, Blazor, .NET Minimal API on kisco.com/products. You can get my NuGet packages original source code for free by signing up. You can, all the code that I produce in the videos, almost all the code, I will be posting to my Patreon, so you can become a member and get access to that. If this video was helpful or valuable, let's hit that like button and subscribe for more.